In the previous unit, we covered Chapter 2 and Chapter 3, where in Chapter 3, you dealt with types and characteristics of processors, selecting and installing a processor. We looked at memory technologies and also how to upgrade memory. In this unit, we'll be dealing with Chapter 4 of the prescribed textbook, supporting the power system and troubleshooting computers. In this chapter, we will be describing the methods and devices for keeping a system cool, selecting a power supply to meet the power needs of a system, demonstrating an organized approach to solve any computer problem, especially hardware problems occurring during the boot, troubleshooting problems with the electrical system, troubleshooting problems with the motherboard, processor, and the RAM. The first learning outcome deals with describing the methods and devices for keeping a system cool. CPUs do not tolerate heat well, and modern processors need active cooling solutions just to function at all. Almost every CPU uses a combination of heatsink and fan assembly to wick heat away from the CPU. Case fans are large square fans that snap into special brackets on the case or screw directly to the case, providing extra cooling for key components. Most cases come with a case fan, and no modern computer should really be without one or two. Processors and video cards are the greatest heat producers. As a result of that, it is possible to get cooling solutions like graphics card fans, fan cards, heat sinks, and RAM coolers. One method of cooling a PC that works by running some liquid, usually water, through a metal block that sits on top of the CPU, absorbing heat. The liquid gets heated by the block, runs out of the block and into something that cools the liquid and is then pumped through the block again. The second learning outcome deals with selecting a power supply to meet the power needs of a system. Powering the PC requires a single box, the power supply, that takes electricity from the wall socket and transforms it into electricity to run the motherboard and other internal components. When building a new computer, you buy a computer case with a power supply, or you can buy it separately. A power supply provides only the amount of power your system needs. If you put a 1500 watts power supply into a system that needs only 250 watts, that big power supply will put out only 250 watts to the system. So buying an efficient higher wattage power supply gives you two benefits. First, running a power supply at less than 100% load helps it live longer. Second, you'll have plenty of extra power when adding new components. Don't cut the specification too tightly for power supplies. All power supplies produce less wattage over time, simply because of wear and tear on the internal components. If you build a system that runs with only a few watts of extra power available from the power supply initially, that system will most likely start causing problems within a year or less. Do yourself or your clients a favor and get a power supply that has more wattage than you need. As a general recommendation for a new system, use at least a 500 watt power supply. This is a common wattage and gives you plenty of extra power for booting as well as for whatever other components you might add to the system in the future. During the selection process, you need to be aware of features like form factor of the power supply. This determines the dimension of the power supply. You need to consider the wattage ratings, like paying attention to the capacity for the positive 12V rail, The positive 12V rail is the most used, especially in high-end gaming systems. You also need to consider the number and type of connectors the power supply provides. You need to consider the fans inside the power supply. The larger the fan, the better job it does, and the quieter it runs. The dual voltage option is also an important point to consider, like seeing that it has a selector switch that you can use to change input voltage if need be. Lastly, you might also consider extra features like knowing that more expensive power supplies are quieter, last longer, and don't put off as much heat as less expensive ones. When selecting a power supply, pay particular attention to the capacity for the positive 12V rail. A rail is the term used to describe each circuit provided by the power supply. The positive 12V rail is the one most used, especially in high-end gaming systems. The original ATX power supplies had two distinguishing physical features: the motherboard power connector and soft power. Motherboard power came from a single cable with a 20-pin P1 motherboard power connector. ATX power supplies also had at least two other cables, each populated with two or more Molex or mini connectors for peripheral power. When plugged in, ATX systems have 5V running to the motherboard. They are always on, even when powered down. The power switch you press to power up the PC is not a true power switch like the light switch on the wall in your bedroom. The power switch on an ATX system simply tells the computer whether it has been pressed. The BIOS or operating system takes over from there and handles the chore of turning the PC on or off. This is called soft power. Using soft power instead of a physical switch has a number of important benefits. Soft power prevents a user from turning off a system before the operating system has been shut down. It enables the PC to use power-saving modes that put the system to sleep and then wake it up when you press a key, move a mouse, or receive an email or other network traffic. All of the most important settings for ATX soft power reside in CMOS setup. Boot into CMOS and look for a power management section. The third learning outcome deals with demonstrating an organized approach to solving any computer problem, especially hardware problems occurring during the boot. An effective troubleshooting theory follows a set of steps to diagnose and fix a computer. Troubleshooting theory includes interviewing the user and backing up data. Second step is examining the system and making your best guess. Third step is testing your theory. Fourth step is planning your solution and then fixing the problem. Fifth step is verifying the fix and taking preventative action. The sixth step is documenting what happened. A good IT support tech builds a strong network of resources she or he can trust when solving PC problems. These sources of help include the web, chat forums, emailing, technical support, using manufacturers' diagnostic software, user manuals, and technical associates in your organization. The fourth learning outcome deals with troubleshooting problems with the electrical system. In this part of the chapter, we look at troubleshooting the electrical system. We look at the possible symptoms of a problem with the electrical system and possible simple solutions. When a computer appears dead with no indicator lights, when a computer locks up during the booting process, error codes or beeps that occur during booting but come and go, the computer powering down at unexpected times, and cases where you hear a whine coming from the power supply while the computer appears dead. Other problems that a computer might go through are intermittent problems. Possible causes of these problems include inadequate power supply, overheating, and devices and components damaged by ESD. Improper contact with the chassis caused by a component on the motherboard can create a short that might completely damage your system board. A missing standoff can most often cause an improper connection. Loose screws under the board might be touching a wire on the bottom of the motherboard, and that can cause a short. Look out for bent out capacitors that can be spotted brown or corroded. Overheating happens for many reasons, including improper installation of the CPU cooler, fans, overclocking, poor airflow inside the case, an underrated power supply, a component going bad, or the computer's environment, for example, heat or dust. A computer might hang after a period of activity. In this case, you can suspect overheating, and the immediate solution will be to go into BIOS UEFI setup and find the screen that reports the CPU temperature. Excessive dust over the components causes them to overheat, and the solution is to use compressed air or anti-static vacuum to remove dust from the power supply, the vents over the entire computer. Airflow inside the case needs to be checked. For example, you might need to replace a fan if there's an empty fan slot on the rear of the case. You might need to install case fan in the slot to allow more air coming in the case. You might need to install more case fans. However, don't do so if the case is not designed for installation of more fans. If the side of the case has a slot for chassis air guide and it's missing it, you must consider installing the chassis air guide. To improve airflow, replace missing face plates over empty drive bays and replace missing slot covers over empty expansion slots. In cases where cables are in the way of airflow, use tie wraps to secure cables and cords so that they don't block airflow across the CPU. In case where the computer is sitting on the carpet, use computer stands so that air can circulate under the case. When the cooler is not connected properly, this might cause overheating. Hence, it's important to verify that the cooler is connected properly to the processor. These are some possible problems and solutions for overheating problem. In this part of the learning outcome, we focus on the problems you might experience with your laptop power system and solutions that might help to resolve the situation. The first problem you might encounter is when the power is not getting into the system. In this case, you might want to verify that the AC adapter is plugged into a live electrical outlet. You can also check the connections on both sides of the AC adapter transformer and check the connection at the DC jack on the laptop. Another solution, if all fails, is to try exchanging the AC adapter for one you know is good. Another problem you might encounter is when the battery is not charging when the AC adapter is plugged in. In this case, the problem might be with the battery or the motherboard. In other cases, it might be that the battery was too hot and a hot battery might not charge until it cools down. Therefore, wait for the charger to cool down and try again. You can also check for physical damages, and lastly, if it doesn't recharge, then you might consider replacing the battery pack.